Hello, my name is Zach, and in this video I'm going to be teaching how to find the determinants of 2x2 and 3x3 matrices. Before that, you should know some important theorems regarding the determinants of matrices. The first theorem is that if a matrix is a square matrix, its determinant will be equal to 0 if and only if that matrix is singular. Now this theorem goes both ways, meaning if the determinant of a square matrix turns out to be 0, then that said matrix has to be singular. The other theorem states that a matrix is non-singular if and only if the equation ax equals to 0 implies that x is equal to 0. Now that we understand these theorems, let's start solving some matrices. Finding the determinant of a 2x2 matrix is very easy. All you need to do is multiply the number on the top left corner by the number in the bottom right corner, then subtract the product of the top right and bottom left corners. From the theorems that we learned earlier, if the determinant is equal to 0, then we know that that matrix is singular, and if it isn't, then it's non-singular. Let's do an example to show off what we learned. Feel free to pause the video and try this one out on your own. Now solving this, since the determinant is 0, we know this matrix is singular. Now solving 3x3 matrices is a little bit more complicated, but I'm sure you guys can do it. Generally, the determinant can be found by using this formula. Basically, we pick the first row and expand along it. Each element gets multiplied by the determinant of a 2x2 matrix that remains when you cross out its row and column, and then we alternate the signs from plus, minus to plus. Let's do a quick example. Pause the video if you'd like to do it on your own. Now to start, we expand along the first row, and then we simplify each part, and we will end up with a total determinant of 22, meaning that this matrix is non-singular. So, to conclude, if the determinant is equal to 0, then the matrix will be singular, and if it's a non-zero value, then the matrix is non-singular. For 2x2 matrices, it's very simple, and for 3x3 matrices, we're able to expand using minors and cofactors. That's about everything you need to know about learning about 2x2 and 3x3 matrices. Just make sure to practice on your own and you'll understand it. Thanks for watching.